Swayam Prabha. Digital India. Educated India.
So, friends, in this lecture we are going to talk about sampling, and the agenda of this lecture is to define sampling, to discuss various types of errors that sample data contain, the concept of standard error, and some precautions which we have to take in selecting different types of samples. Now, you will see that in these lectures there will be lot of backward forward motion. We have already talked about sampling error, and now we are talking about sampling error. Actually, all these 20 lectures must be seen as a package, and I hope that at the end of 20 lectures you are able to understand some concepts of statistics which you can logically and appropriately apply to your sociological studies, or which you can use to understand the reports of data, census reports, NFHS report, NSSO reports, reports of various surveys conducted by other institutions such as applied economic research or PhD researches more meaningfully. Now, sampling as such means there is a population, this large circle represents population, and you take some units from a part of the population. This is sample. But the requirement of sampling is that although you take only a few units from the population, this is smaller circle from a larger space, such as working women, say 300 working women, 400 working women from Kanpur city, where thousands of women may be working, with the condition that results obtained from these 300 working women can be generalized for all the working women of Kanpur. That is the purpose of sampling, that by is there a way that by making a study of a small number of cases, we can say something about the larger population. So, identify sample which are representative of the larger population. We are not interested in the sample, we are interested in the population. But yes, under certain conditions and by using certain types of sample designs, it is possible to draw inferences which can be generalized for the entire population. And if we can achieve this goal, then sampling is economic. Why should we study the whole population? In census we study the whole population of India, but if the same results can be obtained by studying a part of India's population, say 1 lakh population or 50,000 population or 20,000 population in some way, that results on sex distribution, age distribution, marital status, occupation, languages spoken, mother tongue, fertility, mortality, migration can be generalized for India, then nothing like that. So, this lecture is devoted to sampling. Precisely the aim of sampling theory is to select a part of the universe or population that represents the whole, and to save money, time and other resources. You require much less money, time and other resources to study 20,000 units rather than 5 lakhs. To collect better quality of data. Why better quality of data from samples? Because when you collect data from less number of respondents, you can employ trained researchers, trained interviewers, or you can select researchers and give them specialized training according to needs of the survey and according to the nature of the survey, and you can do back checks, you can manage the quality better, and you can reduce certain types of errors which are called non-sampling errors, which are due to factors other than the fact that you are studying only a part of the universe. This sampling also helps or assists in-depth studies of subsamples. So, you select a sample of 400 and then you may divide them into working women in agricultural sector, working women in service sector, working women in manufacturing sector, etc., primary, secondary, tertiary or service sector, and then take an in-depth subsample of say service sector or informal sector for deeper studies, that is subsampling. This subsampling is done as part of sampling for in-depth studies of certain kinds. So, first of all, by studying only 400 out of lakhs of women of Kanpur city, you are saving money, time and other resources, and then you divide them into primary, secondary, tertiary units, and you can study only one type of working women in the service sector. If your interest lies only in the service sector and you are not interested in manufacturing or agriculture, then why to waste money in collecting data from all types of women. Examples of some important samples include National Sample Survey Organization, which have been collecting periodic data on consumption patterns. At the national level, our estimates of poverty, poverty line, head count ratio, etc., etc., and also this unemployment, occupation, migration, all these are based on data collected through National Sample Survey Organization. So, for policy issues, is the head count of poverty declining? What is the percentage of population today which can be defined as poor? What is the employment rate? What is the unemployment rate? What is employment or unemployment among educated youths? These policy issues or family planning or domestic violence, gender bias, all these things have been studied by using National Sample Survey data. National Family Health Survey data, 4 rounds are completed and preparations are going on for the 5th round. This is conducted by International Institute of Population Sciences, and in National Family Health Survey we have included variety of socio-economic topics. We have data on wealth, education, housing, we have data on fertility, we have data on child mortality, we have data on health, nutrition. We have in the recent past we have also started collecting data through blood samples and on HIV and on various types of diseases like thyroid problem, diabetes. So, we have lots of data pertaining to physical health, mental health, domestic violence, demography, socio-economic data. So, if you are working on any problem related to them, you can use microfiles of National Family Health Survey data. Then there are annual health surveys for different states. The purpose is to collect data on health, health facilities, health indicators, health preferences separately for different states of India. We also have lot of data from annual survey of industries, in which many information based on balance sheets of different industries, different sectors are examined, and if you are working on industry, then you can collect data from annual survey of industries. Surveys are also conducted or given to researchers by national and international planning bodies for monitoring and evaluation of development schemes. For example, one of the important rural development schemes is Mahatma Gandhi National Rural Employment Scheme, and the government often gives surveys to independent consulting organizations, market research organizations and universities, NGOs to get independent evaluation of the schemes midway and at the completion of the schemes. So, midway evaluation or monitoring helps in better monitoring of the programs, and end point evaluation shows the impact of the program. Then there are academic surveys conducted by universities and doctoral students. Yours will be one. I think after doing your MA and MPhil, and many of you may enroll for PhD, and in PhD you may have to conduct a survey. Usually in our country PhDs are based on primary survey. MPhil thesis is usually based on secondary survey from data collected from these sources, and PhDs are based on primary sources, the data which you yourself collect to test your hypothesis. Some important terms in sampling are population or universe. Population is the whole population for which results need to be generalized. Then from population you come to target population. Maybe target population is less than the population or universe. Target population is that in which sampling will be done. The target population may be different from the entire population, like you may be interested in fertility among Muslim women, and the target population may be women who have been enumerated in the census. There may be many women who have not been enumerated in the census for some or other reason. They are part of the universe or population, but they are not part of the target population. If you are using census data, census household data, data according to rural areas, rural units or urban wards for choosing your sample. Sampling frame is a sort of listing of all the units of the target population among which sampling will be done. And sample units, the term sample unit is it refers to those units which have been selected in the sample. Sample units are part of samples. Sample design refers to the methodology of sampling. You may use various types of sample designs, we will talk about them: simple, random, stratified, systematic. There are purposive, probability, many types of sample designs, and single stage, multi-stage. The term sample design refers to broad methodologies of sampling. Now, in sampling there are some errors. We define some errors into two broad categories of errors: sampling errors and non-sampling errors. Sampling errors arise due to the fact that one is not studying the whole population, but a part of it, whose characteristics, for example, mean, or variance or correlation coefficient between two characteristics may differ from that of the population. Mean number of children in the sample or mean income of working women in the sample may or may not be same as in the population. So, mean income of sample units, women who are included in the sample may differ from the mean income of all the women included in the target population or universe. This kind of error is called sampling error, error which arises due to the fact that we are not studying the entire population, we are studying only a part of it. Basically, it refers to sampling fluctuations, a phenomenon by which results obtained from the study might differ from sample to sample. Non-sampling errors, this is another category of errors, and non-sampling errors include all other types of errors, mistakes or system deficiencies which affect the results, including wrong recording of data, errors in calculation, errors in reporting, poor sampling methods or behavioral effects. Age heaping arises because of digit preference. That is not because of sampling error, not because you are studying only a part of it. Whether you collect data from sample or census, the phenomenon of age heaping to which I referred in the previous lecture will exist, or under-reporting of ages or over-reporting of ages. These problems will exist, or social desirability. Problems associated with wrong, deliberately wrong responses will exist whether you conduct a sample study or a census study. This is part of non-sampling error, or you wrongly enter some figures in your computer, in your Excel sheet or SPSS sheet, that is also part of non-sampling error. Means all those errors which have nothing to do with the sampling part, sample design or sample size, they are called non-sampling errors. There are many sources of non-sampling errors, and they include failure to measure some of the units due to failure to locate some individuals. And maybe the individuals whom you have failed to locate are not representative of the entire population. Maybe their characteristics differ from the characteristics of others who are included in the sample, and this problem will become a source of non-sampling error. Errors of measurement on a unit. All measurements are dependent on methodologies, on instruments, and errors related to instruments and measurements are part of non-sampling error. Non-response bias. There will be many people who will not respond to you, they will not answer any question, or they will answer some questions, but not others, and therefore, against many questions you have to write non-response or missing. Careless data collection can also be a source of non-sampling errors. Errors of classification, data entry errors, inappropriate analysis. Suppose you have to apply t-test, but you are using z-test, conditions of z do not meet, say sigma is not known, it has been estimated from the data itself. So, you must apply t-test, but you are using z-test. That kind of error in findings of sample data is also part of non-sampling errors, or misrepresentation of facts deliberately by researchers. All other types of errors, telescoping, reference period, etc., are part of non-sampling errors. They have nothing to do with sample design, sample size. Now, how these errors vary with sample size can be shown in the form of graph. See, sampling errors, this graph shows what happens to sampling errors as sample size increases. This graph shows the sampling errors. As sample size increases, sampling error or error in estimate of sample decreases. Now, non-sampling errors increase. All types of non-sampling errors increase, and sum total of sampling error and non-sampling error therefore behaves like this. Initially, with increase in sample size, total error decreases, and beyond a certain point, total error starts increasing. This sampling error is also called or is measured by standard error. Standard error is an estimate of sampling error. What is standard error? To calculate sampling error of mean for understanding purposes, write down all possible samples, calculate mean of all the samples, calculate their standard deviation, and you have sampling error. Standard deviation of sample mean for all possible values of sample mean will be called standard error of sample mean. In practice, you will have only one sample, you will not have all possible samples, and whatever estimates you will obtain will be obtained from study of one sample only. So, even estimate of standard error will be made from one sample only, and sample researchers, statisticians do not find any problem with that. Before proceeding further, let me also tell you that a large sample is not always better. Some people think that larger is the sample, better would be results. That is true, then census will always show better results than sample, which is not the case. For many purposes, we do not depend on census data. Census data on fertility, etc., is not considered to be reliable, although census estimates are based on data obtained from all the individual slips for more than 1.2 billion people. We rely more on sample registration scheme data for fertility. So, sometimes fertility data from samples is of much better quality than the census data, and one of the reasons is that increasing sample size makes sense only up to a limit. You have seen that once you cross that limit, once you have a larger sample than that, then the total error in the results, sampling error plus non-sampling error, start increasing. Large size of sample is therefore not always better, and you have to decide what should be the optimum size of sample for your study. More on standard error. Ratio, you will find that if you look at reports of NFHS, you will find they have given estimate of means, estimate of proportions, and standard error, and also relative error. This ratio of standard error to parameter mean or proportion is called relative error, because amount of errors, sampling error makes sense only in relation to mean or proportion value of the parameter. You remember in talking about univariate analysis, I defined coefficient of variation as sigma divided by m into 100, it is something like that. Relative error is standard error divided by the value of mean or proportion, whatever you are estimating, and this is called relative error. Then confidence interval. One advantage of calculating standard error is that you can specify lower and upper limits of the estimate with certain degree of confidence. You can not only say that average income of the population is estimated to be this, you can also say that I am 95% sure or 90% sure or 99% sure that it will not be less than this or more than that. In NFHS, this interval is taken to be plus minus 2 times standard error. So, mean or proportion plus minus 2 times standard error of the estimate is given as confidence interval. This is a great achievement of sampling theory. The degree of confidence is 1 minus level of significance or type 1 error. Type 1 error is defined as probability of rejecting null hypothesis when it is true. So, when I am saying 95% confidence, it means the type 1 error in my results is 5%. If I am saying 99% confidence interval, then the level of significance is 1%. As sample size increases, standard error decreases, and this is taken as the measure of accuracy of sample design. In sampling, you cannot measure accuracy as the difference between sample results and true value, because true value is not known. If you knew the true value, you would not go for sampling studies. So, in sampling, error is defined in terms of standard error. The standard error of mean, as we have seen in some previous lectures also, is sigma or standard deviation of the population divided by square root of sample size. So, in sampling theory, error is defined not in terms of difference between observed and true values, but in terms of sampling error. Consistency of possibility of consistency in the results obtained from different samples. If standard error is 0, it will imply that all the samples will produce the same results. If standard error is very high, it will mean that different samples produce differing or varying results. That is why their standard deviation is high. The standard deviation of all possible values of the estimate of interest. Estimate of interest may be mean, median, mode, geometric mean, harmonic mean, correlation coefficient, regression coefficient, anything you calculate from sample data will have a standard deviation of all possible values or standard error. This so, if you calculate correlation coefficient between two characteristics from sample data, you can also imagine that similar value can be calculated from all possible samples, and the correlation coefficient may vary from sample to sample. To what extent, that needs to be seen, but correlation coefficient will vary from sample to sample, and the standard deviation of these variations is called standard error of correlation coefficient. Even in other analysis like regression analysis, regression coefficient will vary from sample to sample, and standard deviation of variations in regression coefficient from all possible samples will be called standard error of regression coefficient. A high standard error means that the possibility of change from sample to sample is high, and we do not want this. We want standard error to be less. A low standard error is, however, not the guarantee of accuracy. It does not mean that if standard error is less, then the observed values are close to true values. Let us take a population with 6 values 5, 7, 2, 10, 0 and 50. Now, from this population you can draw a sample of 1 unit. For example, you can draw 10. You can draw samples of 2 units. How many? Out of 6, 15 samples of 2 units are possible, like 7 and 0 or 5 and 2 or 7 and 50. Similarly, 3 units, if you draw 3 units from 6, 6 C 3, then you have 20 possible samples like 5, 10, 0 or it can be 2, 10 and 50. Results will vary from sample to sample. And if you have mean of all 20 samples and calculate their standard deviation, that will be called estimate of standard error of sample mean. I am repeating this because to me the concept of sample errors, concept of sampling error is the soul of sampling theory, and you should be very clear about the concept of sampling error, what it is not, what it aims to achieve and how you can make use of the concept of sample error for drawing inferences. If you draw samples of size 4 out of 6, then you have 15 possible samples like 5, 10, 0, 50 and all 15 samples may give 15 different results. Or if you draw 6 units from 6, then you have only 1, that is the census, but if you draw 5 units from 6, then there are 6 possibilities, 6 C 5 or 6 possibilities like 7 to 10, 0, 50 or 5 to 10, 0, 50. There are 6 such possibilities. In each case different samples may produce different means. These fluctuations in means are due to sampling fluctuations. In every case standard deviation of mean will be called standard error of the mean. Sampling errors, there are 2 things you need to understand in sampling errors: bias and precision. It is like reliability and validity. And this bias is equivalent to validity, measure of validity, precision is equivalent to reliability. Accuracy depends on the sampling variance of the estimate and bias. Mean square error is the sampling variance of the estimate plus bias square. So, this mean square error depends on both sampling variance of the estimate and bias square. Bias is a term, that means we have to reduce both sampling variance of the estimate or sampling error as well as bias to get accurate results. Bias is a term which refers to how far the average statistic lies from the parameter it is estimating. Errors from chance will cancel each other out in the long run, those from bias will not. If there is a systematic bias, that bias will be reflected in results from all the samples. Precision is a measure of how close an estimator is expected to be to its mean value from different samples. This is this precision is measured about sampling error. Sampling theory is about precision and it is not about accuracy as such. Like you see here, these 2 are precise samples, these are imprecise. The property of precision is that results obtained from different samples are similar. In one case they are all concentrated here, another case they are concentrated here around the truth, they are far from truth, they are biased, they are unbiased. In case of imprecise results, these findings are widely scattered, though in one case on one side of the truth and in another case on all sides of the truth. When they are scattered around all sides of the truth, they may be unbiased, but they are imprecise. In this case they are imprecise as well as biased. This is the worst situation, this is the best situation. We aim at this, but we have to explore whether we are here or here or here. For bias, calculate the difference between the expected value of the estimate and the true value of the parameter. Expected value of t if t is the estimate minus mu if mu is the parameter. For precision, calculate the standard error of the estimate or sigma t or standard deviation of t over all possible samples. Now, probability theory helps and probability theory is mathematical. Mathematical theory helps in defining standard errors of estimate of a population parameter under certain assumptions. The aim of sampling theory, what I have understood, is to derive mathematics for estimating standard error of estimate for population parameters under different types of sample designs and under different assumptions. The simplest assumption in drawing a probability sample would be that each unit in the population has the same probability of selection. What can be simpler than this? That you are drawing a probability sample on the means a sample based on chance, not according to your choice or convenience, and the probability of selection of all the units of the population is same. Such a sample is called a simple random sample and is the backbone of sampling theory. Let me repeat, your sample may be chosen according to your convenience, your judgment, that is non-probability sampling, and the sample may also be chosen according to laws of chance. Actually, the whole enterprise of science is about making the studies neutral, dispassionate, value free and independent of researchers' bias. If you go according to researchers' convenience or judgment, it may be the best possible judgment, and maybe sometimes non-probability samples give you better results also. There have been several studies comparing results of purposive sampling with probability sampling, but that is a different issue. In probability sampling, we are trying to make the decision regarding selection of sample objective, value neutral, independent of the likings and dislikings of researcher or independent of his prejudices, values, theoretical frameworks, and in a way making them more scientific. In probability sampling, that sampling in which probability of selection of all units in the population or all units on the sampling frame is same is called simple random sample. Variance of the estimate of population proportion for simple random sample is this. This is mathematically derived. It is simple to derive, and mathematics shows that variance of proportion is capital P, capital Q divided by small n, capital N minus small n divided by capital N minus 1. And standard error of P therefore would be square root of this thing or square root of this whole expression. Thus, it depends on population parameter P and thereby on Q, sample size N. PQ is such a thing that as P increases from 0 to 0.1, 0.2, 0.3, PQ will increase, and for P equal to 0.5, Q equal to 0.5, you have the highest value of PQ 0.25, and as P goes further, it increases further beyond 0.5, it becomes 0.6 or 0.7 or 0.9, the value of PQ starts declining. So, if P rises from 0 to 0.5, variance of P will rise or standard error of P will rise, but beyond 0.5 further increase in the value of P leads to decline in standard error of P. That means, if p is close to 0 or 1, standard error is the least, and if p is close to 0.5, then the standard error is maximum. Standard error also depends on population size, capital N, and in terms of p, standard error is highest when p is 0.5, as pq equal to 0.25 is the maximum value of pq. Very large populations, this n minus small n divided by n minus 1 may be equal to 1, it may be ignored, and the variance of p reduces to pq by n. I was telling that estimates of everything in sampling theory are made from sample data. Standard error of p is pq by n, but p and q are not known. They may, however, be replaced by small p and small q, which are the values of proportions obtained from sample data itself, and then V p equal to small p small q by n, this becomes the estimate of variance of p based on sample data. Variance of mean, likewise, as you have variance of proportion, you can have variance of mean, and it is given by this formula. Again, it is mathematically derived. It is capital S square, capital N minus small n divided by small n and capital N. For large values of n, it reduces to capital S square by n, and therefore, standard error of sample mean is S by root n. S is the standard deviation of population units. Since capital S is not known, it is also estimated from sample data. Now, sampling methods, I have just mentioned about two types of samples, probability sample and non-probability sample. In probability sampling, selection is done by chance, is considered to be scientific and objective, for which sampling theory can be developed. Non-probability sampling means selection by researcher is based on researcher's judgment, for which no sampling theory is applied or can be applied, though it can sometimes yield better results, more accurate results. There may be mass sampling, this we might take up while discussing experimental design, and independent sampling for comparing the findings for different ways of measuring or for interviewers' bias. Probability sampling is divided into these types of sampling: random or simple random. Simple random is also called random. I have already defined simple random. Then stratified, we will take up these sampling designs in the next lecture. Systematic sampling, cluster sampling, other designs including multi-stage sampling design. In practice, we generally go for multi-stage sampling. Multi-stage means imagine that you have to study something at the national level, but collecting simple random sample at the national level would be very difficult. You want to study, say, a number of children ever born and children surviving. In principle, you can think of a simple random or stratified or systematic sampling for India as a whole, but making sampling frame for India as a whole, listing of all the women in reproductive age group for India as a whole is a huge task. So, what we do, we first select certain states in India, then within those states we select certain districts. In those districts, we will select some rural pockets and some urban wards, and in those selected rural pockets and urban wards, we will select some households, and in households we will go to women. So, the sampling is done at several stages, and it is also possible to use different types of sample designs at different stages, and that gives us multi-stage sampling. So, in practice, in large surveys like NFHS, we go for multi-stage sampling. Random sampling procedures, how do we get a simple random sample? It can be the lottery method of picking numbers out of a hat or a bag, but this method will apply to small populations only. You may also use the table of random numbers or computer generated random numbers to select simple random sample. Utility. Simple random sample is more suitable for small populations for which a sampling frame is available. Is at the root of sampling theory. All other theories, all sampling theories for other more sophisticated designs are rooted in the theory of simple random sample. When the size of units varies, probability proportional to size method may be more desirable than simple random sample. It is like selecting some respondents from villages of different sizes. In simple random, you need a complete listing of all the possible respondents or subjects. In probability proportional to size, we decide that probability of selection from larger villages should be larger than probability of selection from smaller villages. This is also a way of conducting scientific probability based sampling independent of the choices of researchers. But it has some limitation, that is why we talk of other sampling procedures. Simple random is inappropriate for very large populations or when there is a lack of sampling frame. If you do not have a sampling frame, if you do not have a complete listing of all working women in Kanpur city, you cannot draw a simple random sample of working women from Kanpur. It is costly. Simple random is costly. If we draw a simple random sample of size 300 from India, maybe to meet one sample you have to go to Pondicherry for another sample, you go to northeast for another sample, you go to Haryana or Punjab for just 1 unit or 2 units, you have to go to Madhya Pradesh or Uttar Pradesh. It is very costly. You are travelling too much and contacting a few units only in one travel. Then despite the fact that it is the probability of selection of all the units is same, extreme sample is a possibility. Sample with extremely high values or sample with extremely low values is a possibility in simple random sampling, and it is less representative than some more efficient designs to be discussed in the next lecture. So, although simple random sample is simple, easy to understand, easy to follow, you can use random numbers or lottery method for small populations, but the biggest problem in simple random sample is the requirement of sampling frame. Requirement of sampling frame and difficulty in drawing simple random sample from large population. These are the difficulties, and then on top of that there is also a possibility of getting extreme results. All the sample units may be from those parts of population where their values are low or from those parts of the population where their values are high. Researcher has no control over simple random sample. More advanced probability sampling procedures will be discussed in the next lecture: stratified, systematic, cluster, multi-stage. Multi-stage to some extent I have already defined that we take a sample at first we divide country into states and states into districts into urban wards, rural pockets, and then select some households from these areas, and then households and then respondents. One advantage of multi-stage sampling is that you can be more flexible at different levels of sampling. You may choose certain states purposively and then take random samples of districts, or the scenario would be like this. We want to study the process of demographic transition, and we might feel that the demographic transition may follow different routes in different states. So, in multi-sampling, when we have to make a selection of states, we may select Kerala where fertility declined first. You must have heard of Kerala model of development and Kerala model of demographic transition. Another state we can select is either UP or Bihar, where fertility is still quite high. We may select a state like Odisha, where fertility has declined, but mortality has not declined so much. We may also pick up a state like Tamil Nadu, where fertility has declined more due to administrative interventions rather than other factors. So, you have a broad scenario. You say that I will conduct this study in Kerala, in UP, in Tamil Nadu and in Odisha. You are not selecting these states randomly, you are choosing them according to some research criteria. And then for districts you can use simple random sample, you can use stratified sample. According to development you can stratify different districts, and from each stratum at each level of socio-economic development you can select some districts randomly or purposively, etc. So, then non-probability, let me also spend a few minutes on non-probability sampling, because sometimes non-probability sampling procedures are considered to be better or the only option. This non-probability sampling is restricted to population readily accessible or convenience. This may also be called convenience sampling, because it is convenient to collect data from certain units of the population. So, you contact them. Another variety of sampling which is something similar to simple random is incidental sampling, which is selected haphazardly. I want some study of students' response to some policy measures, academic, administrative. I go to different hostels, and by chance or incidentally, whoever is available to me in the mess or in the reading room at that point of time is selected, and I interview them. That is incidental sampling, by chance. But you see, because I am not introducing any, I do not know that when I go to a hostel which students will be found in mass or in reading room. So, I am not using my judgment, it is free from my biases, my prejudices, but it is of course not as good technically as simple random sampling. Judgment sampling means and I depend on typical units in a small heterogeneous population. If the population is small and heterogeneous, I may like to interview different types of units. These days we are talking so much about GST, and if I want to know what is people's response to changes made in GST yesterday, the typical units can be big businessmen, middle level businessmen, small businessmen, traders, general population, housewives and officials from tax departments, typical units. And in judgment sampling, I am using my judgment that responses from these units may be different, and I must have a feel of how these different parts of the population are responding to changes made in GST. The perspective of a big business, a big trader and the perspective of a small trader, a small businessman, the perspective of administrators, the perspective of tax officials, the perspective of housewives may not be same. So, this judgment sampling will help me in getting representative data for the entire population by selecting units from perceivably different parts of the population using my own researcher judgment. Quota sampling is something similar to judgment sampling, but we divide population into a number of categories and fix quota for that. Like we may fix that for this particular study we would like to contact so many men, so many women, so many educated people, so many uneducated people, so many Hindus, so many Muslims, and by fixing these quota and using non-probability or purposive sampling, we can draw the units for generalization or for representing the whole population. Then multi-stage sampling can be a non-probability sampling. As I chose some states according to a fixed criterion, I may also choose districts according to criteria. So, after choosing that we will conduct the study in UP, I may decide that I will take samples from a western UP district like Meerut, a central district like Lucknow, and an eastern UP district like Varanasi. That is multi-stage. Multi-stage sampling may use judgmental sampling at different stages or respondent driven sampling. This is especially useful in studying hidden or stigmatized population like transgenders or people living with HIV/AIDS. I get a list of them through NGOs which are working among them, and then after studying a few of them, I would request them to give me names, references of some more people who can give me data on HIV or volunteers. In medical experimentation, in tests of drugs etc., you always depend on volunteers. It would be unethical to conduct research on unwilling sample. If the cancer patient want to be treated with old drugs, you cannot force them to take new drugs. Now, this is an example of quota sampling. Men, women, chocolate buyers, respondent quota, 40% should be men, 60% should be women. I fixed in advance that in the sample I will take 40% men and 60% women. So, if the total sample has to be of size 200, then 80 should be men and 120 should be women. This is an example of snowball sampling. You start from here, collect data from this person and take help of this person to get you introduced to these two and then collect data from it. As I said that for working with hidden population, people suffering or people having HIV/AIDS, you cannot have a sampling frame, you cannot use any other method. It is the only possible method that through NGO, after building rapport with an NGO, you interview somebody in the NGO office or in the field, then that person takes you to these two persons and in confidence you collect data from them. Once they become comfortable, they can introduce you to other people living with HIV at different locations. One of my students studied behavior of men having sex with men. This men having sex with men or homosexuals in the wake of HIV epidemic in Bombay metropolitan city, and he used this method. So, this is snowball. This person is interviewed somehow through NGO or your contacts, or you make friends with him and collect data, then he introduces you to these three and each of them introduces you to these people, then you collect data. This is snowball sampling, and the term snowball mean that as a ball of snow in hills, when snowfall is there and you go to see the snowfall. So, if you throw a ball of snow, it keeps on expanding, its diameter, it starts increasing, it starts collecting more snow on itself. So, 1, 2, 3, then like that. So, and your respondents keep on increasing, and this is what snowball sampling means. Thank you.